Today, we're working on this 1988 dirt brown Suburban. Definitely dirt. We drove this thing home a while back, and we haven't had a chance to do a lot with it since. So it's been sitting here, well, for a couple months. So we're gonna check the fluids and fire it up, and hopefully it'll start. I don't know. Got a battery in here. We got a mostly empty radiator. That's not good. Grab some coolant. We got oil. That's good. It's probably going to need a change after a bit, but it's in there. That's the important thing. We got other work to do before we focus on that. Let's find some coolant. Hopefully she doesn't have a leak. I don't know. But let's fill her up with coolant and see what happens. We got coolant. Of course, I'm not going to use a funnel. I'm just going to dump it all over the place. I was just thinking, as I'm pouring this in here, if it has a leak, we probably should be using water instead of wasting this coolant, but I don't think I ever checked the coolant after we brought it home. I don't remember. It's just been too long. We'll just fill it up and see if it runs out. I don't know. Give her a shot. Man, I don't have a big budget for this vehicle, so I hope it doesn't eat through my coolant supply. I was going to say maybe the heater core is leaking, but the heater core's not hooked up. I forgot, we got a new heater core for this. Oh, that's going to be all kinds of joy. I can't wait for that. Let's stick that on there and hopefully she'll fire up. Hopefully the battery isn't dead. Goodness, we got to clean up that coolant catch can. That's just a mess. And of course it doesn't have a lid or anything. Hey, we got new belts on this thing. Look at that. I forgot about that. New brake line, new brake hoses in the front too. He just had all kinds of work done to her. Alright. Probably better than my other Suburban. Let's fire it up. It's running good. I sucked the coolant now. Let's add some more. Well, I don't see her leaking from anywhere yet. I'm kind of surprised she fired right up after sitting like that, but she's running good. Oh, we should check the trans fluid. Where's my rags? I don't know. In there, that's a good sign. It looks pretty good. Not right at the right level for cold, so not bad. Oh, the drivetrain. I mean, drivetrain's good. We kind of knew that. Driving it home. So oil pressure gauge doesn't work, but we assume it's getting good oil pressure because, you know, it runs and doesn't clatter or bang, and I'm hoping it's just a sender. We've got another one we're gonna throw in here, maybe today, I don't know. That's why it's on our list of things to do. Oh, it looks like the AC was checked in 08. So that's a long time, but Better than some of the vehicles we get where the AC's been disconnected for 20, 30 years and nobody knows anything about the state of it. So that's a good sign. Oh, she's running good. Maybe we should move her a little bit. I don't know. Get that transmission flowing. I see a new O2 sensor on the exhaust. Just seeing all kinds of new things on here. So that's good. I don't know that I've looked at it really close before. I'm trying to get it warmed up right now, and I don't remember if the temperature gauge works. Trying to see if we can bring her up to temperature and see if that works. Because if that doesn't work, we gotta probably pull the sender out and replace that, and then you got to drain the coolant out, and now we're back at square one again with the coolant. So you know, that's always fun. It looks like the temperature gauge works. As far as the AC system goes, even the blower fan doesn't work. I might check the fuses first and see if there's something going on there. I'm not sure. The brakes on this thing work fantastic. I think the guy said he had lots of work done to them, so they're all new, and what I'm seeing is verifying that. One of the interesting things about this vehicle is it's still got some of the factory chalk marks on it and everything. It's in real good shape. It's got, I don't know, whatever this means, 47 chalked up there, and I think there's something on the firewall. Maybe it's that one that has it on the firewall. I don't know. I'm constantly impressed when I look at this thing how good condition it's really in. Unfortunately, she's been sitting here, and I feel like I'm abusing it doing that, but I just haven't had a lot of time to work on this, and it's been on the low priority list. So we're gonna hopefully get to it and see what we can do here. One thing with this is I gotta grease this assembly up because it wasn't working right the last time I tried to open the old hood, and we're going to grease this up and slam the hood a couple times and open it and make sure that works, because I don't want to get the hood stuck again where we were. That was not good. This is a cable operated hood latch assembly, you know, standard GM 80s, and you pull this and it's supposed to release the mechanism, but when you slam the hood down, there's a pin up here. You can see it up here, and that latches into here. So basically, if you want to duplicate that with the hood up, you can just fold that into place, and that's like with the hood latched, and then you can pretend to be the cable and pull it here, and it's got a spring up there and it releases like that. So we're gonna grease this and make sure she's in good shape, and then we're gonna play around with the cable. The reason it gets stuck sometimes is not that the assembly doesn't work or anything, but when it's here and you pull it back, it doesn't want to spring up and pull back so it can release the hood. And then of course it's stuck, and the only way to do that is to snake something up through here and push it. So we're gonna grease that up to make sure she's very loose. All the springs are greased up and the assembly doesn't want to stick together. Where's my grease? So I don't know what everyone else uses, but I just use the most heaviest, dutiest, waterproof, highest temperature grease you possibly can, which is ridiculous for a hood latch assembly. Really is, but if you're gonna do something, do it full bore, you know. So I just make sure to work it into the spring for one thing. You don't want your spring to get rusted together. And then where the two pieces of the the two latch pieces come together. You want to work the grease in there real good. The thing with this high temp grease, it's really sticky, and so as you work the assembly, it works back and forth between the parts and kind of transfers and moves throughout the assembly, and that's a good thing. That's what you want. So any part you can't reach, you kind of get like penetrating oil, but grease, and it kind of works its way into the rest of the assembly just by being nearby to other moving parts that are moving along with them. So just want to try to work it in there, and we work the assembly a good bit. The spring that springs this assembly back is actually on the hood. So when I pull this, obviously it's not going to go ka-chunk and spring back like it would when the hood's attached to it. I'm going to make sure, grease it in the open position and grease it in the closed position. And that way, as you work them back and forth between the two, it just gets that grease worked in all the spaces in between those two positions as well. So that's what we're shooting for here. Obviously there's some places where it's hard to get to, like these pivot points. But in this case, the pivot points actually seem to be in good shape. So, and I kind of just wipe off the excess with my screwdriver or whatever I'm using and just work it around. It just helps to get all that grease in there. Like I said, if you want to transfer it from point to point, you want to get it places where maybe it's not contacting now, but it will be as you move it. So move it back and forth. And once we think maybe we have it greased enough, we'll try to close the hood here, and let's get this out so we don't smash our grease container. Set this off to the side. Alright, so let's try shutting it here. So, go pop the hood again here. Well, that worked a lot better than last time. Again. Oh yeah, she's working good now. So now we know we can get back under the hood if we need to. What should we do next? I believe the oil sender is down. I believe it's down behind that exhaust manifold, behind the driver's exhaust manifold. So I'm gonna do that. If there's enough light, I'll take you down with me. It's just standard wrench turning and replacing that sensor, but in case anyone is interested in where they are, and the TBI engines are down below my 86 work truck, it's up behind the distributor where all the older Chevys are that way. Well, not all of them, but most of the Chevy small blocks are that way. So we replaced the oil pressure sender, and we got pressure now. That's cold. We got about 50 psi. She's warming up. She's over 100 degrees, 50 psi. So that's good. She's got good oil pressure. Before we get too much further here, I'm a little bit worried about, catching some of this on fire. So I'm gonna go through here and vacuum out the engine compartment and try to get some of those, squirrel nests and whatever else is in there out of there. I took the battery out. There's our battery tray. Oh, that's a nice piece of wood. I have to keep that. Anywho, there's a lot missing. So we've got a new one here, and we got to open it up. But anyway, inner fender's pretty well gone, but the regular fender down there is very intact, so that's good. I'm not going to complain about the inner fender, so we'll whip this old one out and put the new one in. There's not a whole lot holding that in. My goodness. We got the right battery tray. Put this in here. I even have the bolts, proper bolts around here. Oh, 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 get away from me. A lot of people don't replace their battery trays sometimes when you need to, but they're really not that expensive, you know. Companies know they rot out, so they make a lot of nice reproduction ones. Well, that one goes in from the bottom. Okay. And the new battery tray covers that massive hole in the inner fender well there. Here's my battery cable. Okay. We even have a battery hold down, so I think it's in the glove compartment. Oh, yeah, previous owner was nice enough not to lose that, even though they didn't have a battery tray, so where's my battery? Alright. Put the battery back in. Battery's actually fairly nice. It's pretty new. So, starting with the air conditioner system, the blower fan did not work at all. So what we did is, there's a ground connection here for the blower fan. It grounds on the case, it grounds here, and we cleaned those up, and we also cleaned the resistor up. It was very corroded, but that probably wasn't an issue, but you know, it's always good to keep it clean anyway, reduce heat buildup and whatnot. Cleaned up all our connections, and it works on slow and, well, everything but high. It works on everything but high speed. But the high speed connection is controlled through this relay here, not through the resistor. Everything but high speed is controlled through this resistor circuit. High speed just goes directly to 12 volts, and it uses this relay for that. And I suspect that this relay isn't working. So what we're going to do is get out of there. We should be getting, when we turn our blower fan on high, we should be getting 12 volts from the switch on this orange wire, and 12 volts from the battery that actually goes through this relay to the blower fan. And of course we should be getting ground. Purple wire goes out to the blower fan. The blue is when you're in those lower positions, the blue comes in and bypasses the relay and goes out to the blower fan. But when you have it on high, power comes in through this orange wire, switches the relay, and kicks it off of this blue wire directly over to the red wire. So, yeah, we can eliminate our relay just by, you know, jumping these connections in here if we want to. It could be a bad relay. First, we'll jump the connections and we'll test the relay. It's probably backwards, but that's the way we're going to do it. So, let me figure out what we're going to do for a battery. Oh, we have our temporary battery in here. Let me get my meter hooked up and let's see where we're at. Okay, so we're hooked up to the orange wire, which is power out from the blower fan switch. Got the key switched to on, got the fan switched to high. So when I switch this power box on, we should get, I believe we should get 12 volts. Okay, so our blower switch is good because we're getting 12.4 volts. So my suspicion is the relay is bad. But we can test that. Shut this off. Let's see, the two relay, these are the two relay power connections. So I should be able to hook these up, power, and feel the relay click. And the relay is not clicking when I apply power to it, so it's not switching. I mean, it's a little bit corroded, but not terribly, but yeah, I don't know, maybe we can try the old massaging trick. Sometimes that works. Most of the time it doesn't. Wind just picked up, my goodness. No, she's still not switching. So we need a new relay, and then our blower fan should work on high, and then we can start running through the air conditioning system. Let's get the blower fan working first of all with this relay and see where we're at. So we got our new blower relay. Hopefully this will fix all our blower issues. Let's test it before we bolt that down. Alright, so ignition on. Got our unit on there. Got low, you can't hear it, but it's running. Next to low. Yes? And why does high not work? A little bit of a squeak there. Oh, we still got no high. What's up with that? Right. Let's to negative. Positive. Ow, why is that so hot? Our wiring diagram here. Yeah, 3 and 4. Do we have them reversed maybe? Ow. What's going on here? 3 and 4 activate the relay. What am I missing here? Got the same pin out. Oh, this is interesting. Why is it getting so hot? I'm not sure what's going on here. I should just activate the relay, but it's acting like a short. Well, looking at the old and the new relay, this one has a diode across there, and this one does not. Well, anyway, they are different. Should I cut the diode out and try it? I don't know. You see, it just shorts, it doesn't actually move the relay. Well, what kind of idiocy is this? Guess I can cut the diode and I can always resolder it if it... I don't understand. Alright, well, let's see what happens if I remove that diode. Well, kind of separated the diode there, and the relay still doesn't work when we hook up power, and I don't get continuity across here either, so I guess that means the coil's burned out. I guess our brand new relay is... I'd have to retrofit one in, but I don't know if I have a high amperage relay. I don't know. Well, what am I missing here? This says the coil has continuity. It should work. This is a 5-pin relay. I mean, yeah, according to this, you should only have to energize the coil pins 3 and 4 on the coil, which are these two in the middle. I don't know. I'm confused. I mean, we're definitely getting power out and ground and everything there correctly from that plug. Probably have a 5-pin relay somewhere. I can try replacing it with just a standard relay. No. Let me see what I have. So we got just a regular newfangled relay here, and I don't know if you can hear that clicking. That's what this one should be doing. Let's test this on here. What we should get is when we turn our ignition on and our fan switch to anything but high, the relay should stay open. And then if we turn it to high, you should hear the relay click when I... So let me go in and hit the ignition and get that set up. Okay, so we are on not high, but everything should be on. The relay clicked, that's correct. Now we've got it to high, so when I connect this, the relay should click. It doesn't. Not sure. Oh, no, we're not connected to the right side. Whoops. Do we have to replace this with a different relay, maybe? Well, I don't know what to do here. I don't really want to retrofit in another relay, but... let's see. I really don't feel like waiting for another new relay that's probably also bad. I guess we're just gonna retrofit in a standard relay. I think I actually have a socket for a standard relay. So I guess we'll pull the pins out of there, and I don't know if they'll go into the other socket, but I splice the wires in. All right, well, let's see what we got. Now we got our new relay plug with the pins removed. I don't know if these pins in this one are going to be compatible, but pulled one out here. Maybe they will. Oh, I am so lucky. All right. So I'll pull these, extract these pins here, and then I'll just stick them in the other one, hopefully correctly. And we can just use a standard 5-pin relay. And I don't know if a standard 5-pin relay is going to hold up, honestly. They're not really made for continuous. They're not really made for continuous high voltage draw, but I don't know. I mean, at least we'll have them kind of with a standard relay plug rather than GM's thing going on here. Let's make sure we get these in right, because they're a pain to pull out. Okay, so what's our pin out here? Fortunately, with these relays, they just tell you right on the relay what the pin out is. 85 and 86 are our triggers, but we know that they're over here. So 30 is our power to the blower, and that's not what we want though. We want 30 to the blower output, because we're switching between power and resistor power, battery power and power through the resistor. So normally closed is 87A, so 87 we want our battery power. Kind of see there, looks like 87A is in the middle. So 87A is going to be the blue wire, and 87 is going to be the red wire. Well, we got to do it in our plug, obviously. What to do with it? There it is. So put it into place, and then 87A is going to be blue. That's the middle one, correct? And then pin 30 is going to be our blower fan power. Pin 30 should be, and our other two polarity shouldn't matter on this. Well, they have that extra fold over on the pin. Well, that should be enough for testing purposes. Let's see what happens. Okay, we got high blower fan speed. Let's see if our relay gets too hot. It's actually not getting warm, so that's good. We're feeding a full 12 volts through there, and that motor draws some amperage. That's why they use high amperage wires here. And a relay, of course. Wow, that actually worked. I'll shut it off and get that relay seated. Wow, all they did was ship us a bad relay. Huh. Still use our connection point here. Let me get the proper socket for that. I can still keep her pointed downward so she doesn't get water or anything in there. Well, there, folks, there you have it. So you can easily substitute out a standard relay for these GM blower relays. Apparently the pins just slide right into the relay sockets as long as you have the plastic relay plug. So there you have it. Give her a final test here now that everything's bolted down. Yes, indeed, she works. So I guess, I mean, yeah, I'll have to keep that in mind and remember that. Standard relay substitution for the GM blower relay. And I ordered that new blower relay from the interwebs. That was like a, I don't know, $20 or $30 relay. And that one I put in is, you know, it's a standard, well, I don't know, I probably came off of another project, but, you know, that's your standard like $5 to $10 relay. We'll see if it holds up. It's not developing any heat or anything, so my guess is it will hold up. If you get the right relay, you gotta check your part numbers and everything, which I did not check on this. What's this say? 49400, but I don't know what brand it is. But I'm sure they have a amperage range on them if you look up the part numbers, and you can figure it out. It's a standard 5-pin relay pinout. And that's the important thing, because even if we do blow that relay, we can find a high amperage relay with that pinout rather than this GM 5-pin relay plug pinout that, you know, I guess it's proprietary because they want you to buy their crappy relays. Ow, that's hot. Well, folks, I guess that'll do it for just the kind of getting some of the light stuff operational in this Suburban and getting her to the point where we can get some things underway here. So we can, you know, swap the heater core and work on the AC and some other little projects, do the interior, and so we'll have some more projects coming up next. You know, stick with us if you like what we're doing. Feel free to subscribe, like, comment, whatever. It all helps the channel. It's free. I don't like, you know, everybody says subscribe, 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 and I don't really like doing that because it's common knowledge. You know, if you like it, subscribe, and it helps the channel. People know that, but I don't like doing it. But I guess I've got to. Everybody else does, you know. If everybody else jumps off a bridge, then you've got to jump off a bridge too. So anyway, thanks for sticking with us, and tune in for more episodes on our 1988 Suburban as they come out and as we get some projects done here. And thanks for watching.